Semi-partial correlation, or in another word, part correlation. Semi-partial correlation is different from partial correlation. I have already described partial correlation between two variables in a separate video clip. Here in this video, I will only describe how to do semi-partial correlation or part correlation. This correlation test is a parametric test. The test examines the correlation between two variables when the effect of a third variable is held constant or removed on one of the variables, one or two. So if you have one variable compared to another variable 2, and you have a third variable, then you correlate variable 1 with variable 2 and remove the effect of variable 3 on one of the variable, either variable 1 or variable 2. To do the test, the data has to be normally distributed. The data has to be continuous. The data has to have a linear relationship. Variable 1 and variable 2 have a linear relationship, and there is no outliers in the data. So the way to do it in SPSS, here I have three different variables labeled as data 1, data 5, and data 6. And I want to do a semi-partial correlation between data number 1 and data number 5. And at the same time, I want to hold the effect of data number 6 constant on one of the variable, in this case on variable 6. So the way to do semi-partial correlation is to click on Analyze, and we are going to use regression analysis to perform this parametric test. Here in this box, I am going to move the data into the dependent variable, and I'm going to correlate data with data 1 with data 5, and move also data 6 into the independent. So data 5 and data 6 will be an independent variables. Move them to the independent variables. On the statistics box, I'm going to take on a box that say part and partial correlation. So the software will calculate both the part and partial correlation, and I click on OK. Plot, I'm not going to make any changes, and options, no changes. Here what I'm asking the computer software and the program in SPSS to correlate data 1 with data 5, and at the same time remove the effect of data 6 on only data 5 and not on both 1 and 5. So if I click on OK, the SPSS will generate an output, and in this output, regression outputs, the most important table is the table labeled correlation. Again, and toward the end here we have in the table the correlations coefficient using zero order, partial correlation, and part correlation. For our topic today, this is the important part of the table. In this table, we can see that correlation between data number 1 and data number 5, when we remove the effect of data 6 on data 5, or holding the effect of data 6 on 5 constant, the association between data 1 and data 5 is minus 0.605. So there is a negative relationship, and this negative relationship is moderate, and it is significant as the p-value is less than 0.05. So this table has calculated the correlation coefficient, part correlation coefficient for variable 1 and variable 5, holding variable 6 effect on 5 constant. For correlating variable 1 with variable 6, meanwhile holding the effect of variable 5 on 6 constant, the correlation coefficient was calculated and it is 0.174. This is a weak positive correlation, though it is statistically significant as the p-value is less than 0.05, and it is 0.023 here. So correlating data semi-partial correlation between data number 1 and data 6 controlling the effect of 5 on 6, the coefficient value is 0.174. So in this way, I had shown you how to do semi-partial correlation between two variable 1 and variable 5, simultaneously controlling the effect of a third variable on only one of the variable 5, not variable data 5 and not data 1. Again, the same thing here, semi-partial correlation between two variable number 1 and variable number 6, and holding the effect of variable 5 constant or constant, or removing the effect of variable 5 on 6 but not on variable 1. So this is the way to do semi-partial correlation between two variables simultaneously holding the third variable effect constant on one of the variables.